Suppose we have the following function sum array to calculate the sum of two arrays A and B. Notice that the program has a loop that runs for 100 iterations. Each time the loop runs, the instructions inside the loop are fetched. Here, the loop runs 100 times. This means we are fetching the instructions 100 times. If we have to fetch each instruction one by one from the RAM every time the loop runs, then we'll have to access the RAM as many number of times as the loop runs. This is very inefficient and slows down the program significantly. To solve this issue, we use cache memory. That is, we store the entire set of instructions inside the loop into the cache. Since cache is much faster to access than RAM, the program's performance is optimized. But how does the CPU decide what to store inside the cache? Remember, the cache has a much smaller storage capacity than the RAM, so you can't store everything in the RAM inside the cache. So this is where locality of reference comes in. The ability of cache memory to improve a computer's performance relies on the concept of the locality of reference. If you had noticed already, data often tends to be accessed either sequentially or repeatedly. In other words, computers tend to access the same data again and again, and also tend to access nearby data after accessing some data. Thus, we can make use of this tendency for performance optimization. An example for this would be how we reduce the time taken to access the dates in the spreadsheets by storing a block of sequential dates in cache instead of accessing each one of them one by one from the RAM. The system made an educated guess that the 301st date will be accessed after the 300th date. It made this guess based on the principle of locality. There are two main types of locality of reference: temporal locality and spatial locality. First, let's see about temporal locality. Temporal locality refers to the reuse of specific data repeatedly. The CPU stores data based on the principle that data or instruction accessed recently has high chances of being accessed again. It is the principle a CPU used when it decided to store the set of instructions in the loop into the cache, based on the principle of temporal locality that every time the loop occurs, the CPU would need to access the same data again and again. Temporal locality is the principle that when some data is referenced, there is a high probability that it will be referenced again. Next, we have spatial locality. Spatial locality is the principle that if a particular storage location is referenced, it is likely that nearby memory locations will be accessed in the near future. This again is used in loops when we are accessing a routine of instructions to be accessed in sequence. This principle can also be seen used in accessing array elements one by one in sequence. Not storing the same set of data we last accessed, but the data near it. An example for this would be how the CPU stored 300 to 600th date in the cache after accessing 1 to 300 dates, because it thought that it was likely for the user to access the 301st date after accessing the 300th date.